the circuit of adjacent figure, the diode connected to an AC source to a pure inductance L. The diode conducts for. This is the question they have given in my GATE 2007. The given supply voltage is AC, that is can be represented as Vm sine omega t. Because it is a source, so can I represent the current passing through source? Can I represent it is source current? There is a current is flowing from the anode to cathode of it is anode and it is cathode. So can I write down anode to cathode current? Can I represent it is ID? The current passing through the load, that is inductive load in this case, that can be represented as IL. Instead of inductance, you can connect a capacitor, or you may be connecting an resistor also. The voltage across this one I'm taking, it is VL. If you clearly observe it, the source and diode and inductor all are connected in series. Whenever it is connected in series, I can represent source current is equal to diode current, that is equal to IL. Because too many variables are confusion, that is why can indicate a simple term I. Source current, diode current, inductor current. All are simply I'm indicating by I. Now, when the diode is on, what will happen? This is, can I take it A terminal, and this terminal I'm taking as a B. When the diode is on, it is behaving like a short circuit. Whenever it is short circuit, this can be represented by A, this is B, and this is shorted, and this can be represented by B. Now, whenever the diode is on, the VL is equal to what I can represent? I can represent it is Vs. What is Vs is equal to, can I write down Vm sine omega t. Now, you know the Ohm's law. What is Ohm's law? In case of inductor, I is equal to 1 by L integral V into dt. I am applying the Ohm's law across the output, that is inductor. I is equal to, or you can write down IL is equal to 1 by L integration VL into dt. What is happening? IL can be represented by I, that is equal to 1 by L integration VL. What is VL? Can I write down Vm sine omega t, and this is dt. Now, what is happening? Where the diode starts conducting? The diode starts conducting from 0 onwards. But where it will stops conducting? The diode stops conducting because it is an inductive load. I don't know where it will stops conducting. That is the reason I'm indicating by the time t, because it is indefinite time. Now what I will do, I'm writing I is equal to V is taken outside, L integration of sine omega t, and this is dt. The limits are 0 to t. Now what I will do, it is Vm by L integration of sine can be represented by minus cos omega t. It is dt you are doing, so inner derivative of omega, it will becomes as this, and this is 0 and this is t. Whenever there is a minus symbol, always I will substitute lower limit first and upper limit next. Now omega is taken outside, then what is I is be equal to, what is I is equal to Vm by omega L, and lower limit first, that is cos 0 minus upper limit next. Then what is I is equal to, can I write down Vm by omega L. Cos 0 can be represented as 1 minus cos omega t. This is the final equation what it is appeared in case of inductive load. Now current I is equal to Vm by omega L into 1 minus cos omega t. Any waveform is always drawn between 0 to 360 degrees in a sinusoidal waveform. Now, what I'm going to do, if I'm taking omega t is equal to 0 degrees, what is a current? If I'm writing current I Vm by omega L 1 minus cos omega t. If I'm substituting here, it is 0. Cos 0 is 1. 1 minus 1, it will becomes 0. Now, similarly, if I'm substituting omega t is equal to 90 degrees, then what is a current is equal to cos 90, it will be 0. Then what is the value? It is Vm by omega L. Now, if I'm taking omega t is equal to 180 degrees, then current is equal to cos pi minus 1. Minus of minus, it will becomes plus 1. Then its value will be 2 Vm by omega L. Omega t is equal to, if I am taking 270, then the current is equal to 270, it will be 0, then the value will becomes Vm by omega L. If I am taking omega t is equal to 360 degrees, then cos 360, it will be 1, 1 minus 1, it will become 0. Only in this case, you are taking only 5 instants. You can take it. If I am drawing about the supply voltage waveform, this is 180 and this will be 360. This is supply voltage, it is sinusoidal. It is 0. This is 90. This is 270. Now, if I am drawing the source current or diode current or inductor current, all are same. If I am taking all are same, I, then at 0, the current is, it is 0. Yet at this point, at 90, the current is Vm by omega L. Vm by omega L. At 180 degrees, already we have given all these values, 2 Vm by omega L, and at 270, it will be again Vm by omega L, and at 360 the current value will be 0. Now, what is the observation? The diode start conducting at 0 onwards. Once diode starts conducting, where it will stops conducting, where the anode current should comes to 0. Whether the supply is positive or negative, it is not bothering. Only the diode stops conducting only when the anode current should comes to 0. Where the anode current is comes to 0, it is at 360. That means it is started at 0 and stops at 360. That means what is the conduction period of the diode? The conduction period of the diode is 360 because started at 0 and stops at 360. Then conduction period of the diode is 360 degrees. The right answer for this question is 360 degrees.